All right, so we're back with some more conversion tables, lessons 21 and 22. So let's see what we got. So I'm gonna go ahead and put my table up here, and my table is feet to inches. So this is like using a ratio table to show measurement conversions. So we have learned that, hopefully you've learned that your customary units of length, we have feet and we have inches. And we know that there is 12 inches in 1 foot. So I have created a ratio table to express those measurement conversions. So for 1 feet, I have 12 inches, and 2 feet, I have 24 inches, 3 feet, 36 inches, and 4 feet, 48 inches. So just like we've practiced before, once you have your table, it's very easy to answer your questions. So if I give you 48 inches, how many feet are there? Well, it's very easy to see from this table that it's going to be 4 feet. So let's take a look at some math, okay? So here is some crazy math that we can do. All right, crazy math. I know that the table, you could use the table and find the information very quickly, but now we're trying to use equations to do it. But why not use something super simple to figure out a new concept, right? So what I say is I write my ratio of 1 foot to 12 inches, okay? I'm gonna multiply it by what they give me, which is 48 inches. And you put your labels there, you see that? And then you go ahead and give your whole number denominator of 1. I really hope you guys are listening and not just copying. So you write your 1 to 12, you multiply it by 48, give it a denominator of 1, and then you just cross eliminate, okay? So we cross out our inches because this is some really advanced algebra stuff, but it's interesting how they're teaching this in ratios. But if your numerator and your denominator are the same, right, then you can eliminate it. It becomes 1. And you guys do know that if your numerator and your denominator are the same, they become 1. You can eliminate it because it's 1. And anything times 1 is itself, right? So here we can do the same thing with variables, because obviously the variables are the same. Here we're doing it with measurement units, or a unit. So here, 1 over 12, the inches is in the denominator, and here the inches is in the numerator. So they cancel each other out. So when you're multiplying two fractions, if the numerator, something in the numerator is the same as something in the denominator, you can eliminate it. We'll practice that, okay? And then what we have left is we have the 1 foot and the 12, the 48 and the 1. So here we say 1 times 48, that's my numerator, over 12 times 1, and we have feet left over, so feet is by itself. And then we say that ratio is 48 to 12, and the unit rate would be 4 feet, because we take the 48 divided by 12, because ratios can be written as fractions, and fractions are division problems. The numerator divided by the denominator. So 48 divided by 12 gets you 4. And I wrote that division problem off to the side. So pretty cool. Combining a lot of things that you've learned through the years to ratios that you're learning in 6th grade. We're learning a lot of new vocabulary. We're learning a lot of new ways to write math. But it all comes back to what you learned. So it's just stretching your learning a little bit, taking what you remember and just stretching it a little bit more and applying it to a new concept to hopefully make sense of it. So I know that this piece right here might be confusing right now. Some of you may get it like that. Some of you, we just need to practice it more, and you need to see it more, and that's okay. We're obviously going to be practicing it. This is just the introduction to get your brain thinking. But you should know that fractions is division. Fractions is a division problem. It's your numerator divided by your denominator. That's why I've written it over here. So the answer is 4 feet, which we knew by simply looking at this table, but of course we're taking something simple, okay, to make it, to understand it. So here we have metric system, okay? And so it says how many grams are in 6 kilograms. So what I've done is kind of created, I don't know if you guys remembered, King Henry died by drinking chocolate milk. Kilo, hecta, deca. This is your base unit, okay? Deci, centi, milli. Hopefully you remembered this from last year. But so we have 6 kilograms. So I've created my table. My base unit is 1. That would be just gram, 1 gram. And 1 gram is the same as 1,000 kilograms. Using my conversion chart to remember all of that. So I wrote it here, that 1,000 grams is the same as 1 kilogram. Okay, just to explain this a little bit, I think I just said 2 words backwards. But these are your bigger units, and they get smaller, okay? They get 1/10 smaller. So if your unit is grams, it takes 1,000 grams to make 1 kilogram. It takes 100 grams to make a hectogram. It takes 10 grams to make a decagram. And then you have your 1 gram. And then it takes 1/10 of a decigram to make a gram. Or there is 1/10 of a gram in a decigram. There's 100th of a gram in a centigram, and there is 1,000th of a gram in a milligram. So hopefully that makes sense. So you just kind of count how many place values. So if you have 1 gram, you multiply it by 10 to get how many grams you need for deca. You multiply it by 100 to find out how many grams you need for a hecto, and you multiply it by 1,000 for kilo. Usually kilogram is the one we use the most, or just gram. I haven't really seen a lot of centigrams. I've seen centimeters, but anyways, so your ratio for grams to kilogram is 1,000 to 1. So we want to know how many for 6. Well, obviously we can do the math very easy, but we want to practice this equation. So we say we have 6 kilograms, and we multiply it by the ratio of 1,000 grams to kilograms. And then we cross-eliminate our kilograms because this is in the numerator and this is in the denominator, and we have grams left over. So what we have left is 6 times 1,000 over 1 grams, which is 6,000 grams. I know, you guys are probably wondering, why are we making this look so complicated for such a simple conversion? And again, we're just trying to use simplicity to apply it to something a little bit more complex, because eventually you're gonna be doing things like this. So just understanding the cross elimination when you're multiplying fractions, that things in the numerator, if they're the same as the denominator, you can eliminate them and then just work with what's left over. So if you have any questions, let me know. We'll practice more in class.